Hello students, this is Mr. Maat with another physics lesson. In this lesson I want to focus on two homework questions from the previous lesson, and I created a handout that is attached to this movie and that is about amplitude, wavelength and that kind of things. There is some homework for next lesson, so make sure that you finish that as well. Okay, homework from lesson number 5, one of those questions was this one. Question number 11. Sound A has a frequency of 400 Hz, sound B 200 Hz. Sound A and B are played equally loud, so that's important. So the amplitude is the same, the volume. For someone listening to the two sounds, how would B compare to A? Well, they are different in frequency. They are the same in loudness, so you hear the same volume, but sound number A has more waves per second than sound number B. It has 400 waves per second, and the other one 200 waves per second. So the more waves, the higher the pitch. Which sound has the longer wavelength? Well, the longer wavelength, of course, is the one with less frequency, because the waves just stretch over that second. So, if the frequency of sound B is less, that means there are less oscillations in 1 second. The wavelength for each wave is then longer. So that was question 11. Let's focus on question 12. Use the periodic time equation to work out the following. The cycle time of a sound whose frequency is 660 Hz. Well, thing that you need to do, write down all the things that are given. Well, in this case it's 660 Hz, that's the frequency, and that is of course given in a standard unit. The cycle time or the periodic time is my question mark. You use the standard formula and you just fill it in. You get an outcome 1.5 times 10 to the power of minus 3 seconds. Well, and the second one, you need to calculate the frequency and the cycle time is given. Also, the cycle time is given in the standard unit, so you can just fill it in and you get 25 Hz. So 25 waves per second. Most humans are able to hear that because our range starts at 20 Hz per second. 20 Hz. Okay, now I'm going to explain the questions of handout number 2.8.6. Again, it's attached to this video, so you can just download it and do it yourself. Okay, assignment number 2. Place on the right graph a quiet sound of low frequency, a loud sound with a high frequency, a quiet sound with a high frequency, and a loud sound with a low frequency. So we're talking about the frequency and the loudness, the amplitude. Well, the first one, a quiet sound, so not a lot of amplitude, with a low frequency, so not a lot of waves per second. Let's take a look which wave is a quiet wave. So you see that the amplitude on both of those graphs is not that high if you compare it to those two. So it should be one of those. Low frequency, well, over here you see there were a lot of waves per second, so this is a high frequency if you compare it to that one. So the next one, a loud sound with a high frequency. A loud sound tells you that the amplitude is pretty high. So we need to choose between those two. With a high frequency, you see there are more waves per second over there if you compare it to that one. Well, here are the outcomes to the other one. This is of course a quiet sound with a high frequency, and that is a loud sound with a low frequency. Okay, next question. Question 3. Read from the graph what is the frequency of the sound wave. Well, if you want to know what is the frequency, you need to know how many waves there are in 1 second. So you just need to search for 1 second. Well, 1 second is over here, so I just need to count the amount of waves over here. So let's start. This is half a wave, this is one complete wave, this is a second wave and the third wave. So the frequency for this wave is going to be 3 Hz. Calculate what the cycle time, oh, that's not really nice formulated. What you need to calculate is the cycle time and show it in the graph. Well, the cycle time is of course 1 divided by 3 Hz. So you get an outcome of 0.33 seconds. And if you just want to show that in the graph, it's a time for one top to another top. So one complete wave. Okay, this question, you see 2 sound waves in the graph. How many oscillations do you count? Remember, an oscillation is just a difficult word for a wave. So you just need to count the amount of waves. Let's start with the blue one. 1, 2, 3, 4, 5, 6, 7, 8. 8 waves. And the red one, 1 wave, and 2 waves. So, in total, there will be 10 waves. These questions, a lower amplitude means a higher or a lower loudness. Well, the amplitude tells you something about the volume. Lower amplitude means lower loudness. The unit for cycle time, well, it's time, so it's always seconds, and you can also use milliseconds in this case. A higher frequency means, of course, a higher pitch. Cycle time is the same as the periodic time. Increasing the amplitude results in a higher volume, of course, and the unit of frequency is hertz. Well, hopefully you understood all of those questions from the handout. If it's not clear, you can ask me next lesson, of course. Make sure that you finish homework 2.8.6. Thanks for watching. See you soon.